Hello everyone, I am Dr. VRAO. Today I am here with problems based on the concept of buffer solutions. I had given the various formulas to solve the problems on the buffer concept. Okay, so without wasting your valuable time, I shall go through the problems. Okay, problem 1 is calculate the pH of a solution made by mixing of 0.1 molar ammonia and 0.1 molar ammonium sulfate, and the pKb of ammonia is 4.76. To solve this problem, and first of all you should understand the problem, and you should choose the formula which is suitable to solve that problem. So by reading this problem, I came to know that it is a basic buffer, because ammonia is a weak base, and this is ammonium sulfate, salt from salt. Okay, so I came to know that this is a weak that is a basic buffer, and we calculate, we should calculate the pH. So pH of a basic buffer is pH of a basic buffer, and the formula for pH of a basic buffer, or we know that a pH for basic buffer we can calculate POH. We can calculate POH. So we shall write the formula POH. So POH is equal to pKb plus log concentration of salt by log concentration of base. Okay. So already they given that pKb of ammonia, and the pKb of ammonia we can write the pKb of ammonia 4.76 here, and what we required, concentration of salt and concentration of base. First we shall calculate the concentration of salt. Concentration of salt. What they given that by mixing the pH of a solution made by mixing of 0.1 molar ammonia and 0.1 molar ammonium sulfate. So this is the salt, but they didn't give the volume. Then you should take the volume as 1 liter. Okay, so concentration of salt. So concentration of salt can be obtained in moles. What the formula to calculate the concentration? Okay, concentration or moles is equal to what is it called? Moles is equal to concentration molarity into volume in liters. That gives moles. Moles means nothing but concentration of the salt. So they given that molarity of the salt is 0.1, but in pH calculations we should take the concentration in normalities, but the salt concentration is 0.1 normal, and it is a salt, and its N factor is 2, because NH4 twice SO4, NH4 2 NH4 plus and SO4 2 minus. So its N factor is 2. So by multiplying the molarity with N factor we can get the normality, and the volume is 1 liter. Okay, so volume is 1 liter, so we can write it as 0.2. So multiplication of this will give 0.2, and concentration of base. And concentration of base. So what is the concentration of base? 0.1 molar, and there is no N factor, because N factor for ammonia is 1. Okay, so and the volume is 1, so its concentration is 0.1. Okay, so in this what we calculated, that we calculated the number of moles. Number of moles is nothing but concentration of the salt or base. Okay, now we shall substitute these concentration, salt concentration and base concentration in the above formula. So POH is equal to pKb. What is the pKb? 4.76 plus log concentration of salt is 0.2 and concentration of base is 0.1. Okay, so 4.76 and it gives log 2. So this is 2. So log 2 is 4.76 plus log 2 is 0.3. Okay, so 4.76 plus 0.3 gives 6, 7, 10, 1, 5.06. So this is the POH. This is the POH, but what they asked to calculate the pH. So pH, when we know the POH, from that we can calculate the pH. That is pH is equal to 14 minus POH. So 14 minus POH, 14 minus POH is 5.06. So 5.06 that gives the when we subtract this 5.06 that will which comes out to be 8.94. So pH of the buffer solution is 8.94. And the problem 2 is how much volume of 0.1 molar acetic acid should be added to 50 ml of 0.2 molar sodium acetate solution to have a pH 4.91, and the given the value pK of acetic acid is 4.76. First, in solving the problems, first you should understand the problem. You should understand the problem and you should be memorize the formula, memorize the suitable formula to solve that problem. So by reading that problem, I came to know that it is a acidic buffer, because acetic acid is a weak acid and sodium acetate is a salt. So it is a acidic buffer. So what we calculate? We should calculate the pH. So there is a relation between pH from the previous classes. We can calculate the pH of acidic buffer with the formula pH is equal to pKa plus log concentration of salt by log concentration of acid. Log concentration of acid. How would I know the formula? Because they give that pK of acetic acid. Okay, they gave the pK of acetic acid and the pH of the buffer solution. Okay, so pH is equal to pKa plus log concentration of salt by log concentration of acid. Okay, so from this what they asked, how much volume of 0.1 molar acetic acid should be added to 50 ml of 0.2 molar. Okay, so how much volume of acetic acid is to be added to 50 ml of 0.2 molar sodium acetate to have a pH of 4.91. 4.91. Okay, to have the pH of 4.91, what is the volume of acetic acid that should be added to 50 ml of 0.2 molar sodium acetate? So let us say V is the volume of let us say for the sake of my convenience, let us say V is the volume of acetic acid that should be added to 50 ml of 0.2 molar. Okay, I shall take that V is the volume of acetic acid to be added to 50 ml of 0.2 molar sodium acetate. So and we should to calculate the volume, we should know the concentration, we should know the acid concentration, and we should know the pK value. They give that pK value and they give that pH value, but they don't give the volume of acetic acid to be added. Okay, so we should calculate the concentration of salt. First we should calculate the concentration of salt. Concentration of salt. So concentration of salt, they didn't give the concentration of salt. Instead of that, they give that 50 ml volume and 0.2 molar. Okay, 0.2 molar. Okay, when they give the ml 50 ml of what is it called, sodium acetate, and its concentration, we can calculate its concentration. The formula is millimoles. Why millimoles? Because they are given that 50 ml. Because they are given that 50 ml, the volume is in milliliters. Okay, so millimoles, then we are able to calculate the millimoles. So millimoles by total volume, because it is a mixture. Already I told you in the previous classes that buffer solutions, acidic buffer is a example for buffer solutions of a mixture. Okay, so total volume, because V volume of acetic acid is to be added to 50 ml of sodium acetate. So we should take the total volume. So millimoles, how can we calculate the millimoles? Millimoles concentration into molarity into 50 ml by total volume. Volume is volume of sodium acetate is 50, and volume of acetic acid that should be added is we say that V. Okay, so 0.2 into 50, that is it can be written as 0.2 into 10 into 5 by 50 plus V. So it is 2 into it is 2 into 5 by 50 plus V, that is 10 by 50 plus V. So the concentration of salt is 10 by 50 plus V. And let us calculate the concentration of acid. So concentration of acid is equal to, how can we calculate the concentration of acid? Again the formula, okay, millimoles by total volume. How can we calculate the millimoles? Millimoles concentration, concentration in molarity into volume, but they didn't give the volume and they asked to calculate the volume. Then what is that volume? We say that volume is V. So 0.1 into V by 50 plus V. So total volume is 50 plus V. So it is 0.1 into V by 50 plus V. Okay, now we shall calculate the pH. So already they given that pH. What is that pH? They given that pH is 4.91. They gave that pH is 4.91, and pK they given that pK is 4.76. Okay, and plus log concentration of salt by concentration of acid. So concentration of salt is that we get 50 plus V by, and concentration of acid is 0.1 V into 50 plus V. Okay, so we can write this as 4.91 minus I shall take this 4.76 to this side, that is 4.76 is equal to log 10 by 50 plus V into 50 plus V by 0.1 V. So 50 plus V cancelled out, and 4.91 minus 0.76, that is 411, 0.15. That is 0.15. That is what is 0.15 is equal to log 10 by 0.1 V, 0.1 V. Okay. Okay, what we get that 0.15 is equal to log 10 by 0.1 B. Okay, and we can write this as log 0.1 means 1 by 10, then 10 goes to upper side and numerator, that is that becomes 100 by V, 100 by V, and this is 0.15 and this is 0.5. When we take this logarithm to in this side, Okay, this side, that is anti-log, that is 10 power 0.15 is equal to 100 by V, 100 by V, 100 by V. Okay, so anti-logarithm, how can we calculate this anti-logarithm? 0.15. So it can be written as 10 power 0.1 plus 0.05. Okay, that gives 0.15, because 0.1 into 0.05, that gives 0.15. Okay, so I shall take this, I shall write this as 0.1 plus 0.05 is equal to 100 by V. Okay, so 10 power 0.1, anti-log of 0.15 is 0.1 is 1.25, that is 1.25. Okay, sorry, it can be written as 10 power 0.1 into 10 power 0.05, m plus n, m into n. Okay, so is equal to 100 by V. So 10 power anti-log of 0.1 is 1.25 into this is 0.05, that is 1.12. Okay, these are the anti-logarithm values that we should memorize, right? Okay, so is equal to 100 by V. So when we multiply this 1.25 into 1.12, which comes out to be 1.41, that which comes out to be 1.41 is equal to 100 by V. From this we can calculate that V is equal to 100 by 1.41. We can write this as into 100 by into 100, then we can write 10,000 by 141, which gives what is it, 70, which comes out to be 70.92, which comes out to be 70.92 ml. So this is the way to solve this problem, and the volume of acetic acid that should be added to 50 ml of 0.2 normal of 2 molar of sodium acetate to have the pH of 4.91 is 70.92 ml. Okay, so let us go for another problem. Okay, and the problem 3 is calculate the pH of the pH of following mixture, and they given that pK is equal to pKb, that is equal to 4.74. What is the mixtures? 50 ml of 0.05 molar NaOH plus 50 ml of 0.1 molar acetic acid. First you read the problem. Okay, from this problem, by reading this problem, I came to know that it is a acidic buffer. So what they calculate pH, what they ask to calculate pH. So pH of acidic buffer is pH is equal to pKa plus log concentration of salt by log concentration of acid in normalities or moles. Okay, so normalities. So we shall, what they given that they given that the pKa value is, that is 4.74, but what we know that what we should know, concentration of salt and concentration of acid. So when we mix, it is a base and it is a acid. Okay, when we mix the acid and base, there should be a chemical reaction takes place, that is neutralization. So when we add acetic acid plus NaOH, that gives sodium acetate plus water. Okay, so how can we calculate the, we should know the concentration of salt formed by the mixing of NaOH and so acetic acid. So how can we know the sodium acetate salt concentration by writing down the chemical reaction that is taking place between acid and base. Okay, so what is millimoles? Because millimoles is they given the volume in ml, so we can calculate the millimoles. So how many millimoles? Concentration is 0.05 and ml is 50. Okay, so this can be written as 0.05 into 10 into 5. Okay, it can be written as 0.5 into 5, so that is 0.25. So millimoles of acetic acid is 0.25 and millimoles of sodium hydroxide is sorry. So millimoles of acetic acid concentration 0.1 molar and its volume is 50. So it can be written as 0.1 into 10 into 5. So it can be written as 1 into 5, that is equal to millimoles, 5 millimoles of acetic acid. And sodium hydroxide, what is the concentration molarity of sodium hydroxide? 0.05 into what is the volume? 50. So this can be written as 0.05 into 10 into 5. It can be written as 0.5 because when we multiply with 10 it becomes 0.5 into 5, that is 0.25. So this is the limiting reagent. Okay, this is the these are the millimoles of acetic acid and NaOH. After the reaction, okay, 2.5 millimoles of acetic acid is there and there is no 0 and these millimoles of 2.5 millimoles of sodium acetate is formed. Okay, na? So by we came to know that the concentration of sodium acetate is 2.5 moles. Okay, 2.5 moles, and we know the concentration of E acid, that is 0.5 molar, 5 moles. Okay, that is 5 millimoles. Okay, now we are able to calculate the pH. pH is equal to pK. What is the pK? 4.74 and 4.74 and plus log concentration of salt. Salt concentration is 2.5 and acid concentration is 2.5 and the acid concentration is 2.5 and the acid concentration is 2.5. Okay, acid concentration is 2.5. So it comes to 2.5 by, that is 1 and log 1 is 0 and this is pH is 4.74. The pH is 4.74. Now let us calculate the another problem. Let us and the problem B is here the NH4OH and HCl. It is a weak base and it is a salt. Okay, so that is a basic buffer. So for the basic buffer we can calculate the POH. So POH is equal to pKb plus log concentration of salt by log concentration of base. Okay, log concentration of base. So we should calculate the concentration of salt. Okay, salt formed from the NH4OH and NH4 HCl is NH4Cl. Okay, so the reaction between NH4OH plus HCl gives rise to NH4Cl plus water. Okay, this is the reaction takes place between ammonium hydroxide and hydrochloric acid. Okay, NH4OH. So we shall calculate the we need concentration of salt. We need concentration of salt to calculate the pH of the mixture, but we are able to calculate the POH. From this POH we can calculate the pH. Okay, so NH4OH, what is the concentration of molarity of NH4OH? 0.1 and its volume is 50. Okay, and what is the concentration of HCl? So sorry, 0.1 into 10 into 5, it can be written as 1 into 5, so that is 5 millimoles, and HCl is its concentration molarity is 0.05 into 50. This can be written as 0.05 into 10 into 5. Okay, so it can be written as 0.5 into 5, that is 0.25. 0.25. So this is before the reaction. After the reaction is over, okay na, so it is the limiting reagent and 2.5 millimoles of base is remains, okay, and this is 0, and the concentration of salt is 2.5 millimoles, okay. So 2.5 millimoles. Now we are able to calculate the pOH. So pOH is equal to pKb. What the given pKb value is 4.74 plus log concentration of salt by base. Concentration of salt is 2.5. Concentration of salt is 2.5 and the concentration of base is 2.5. The concentration of base is 2.5, which gives 1, and log 1 is 0, and pOH is 4.74. This is the pOH, but they asked to calculate the pH. pH is 14 minus 4.74, which comes out to be 9.225 or 26. Okay, 25 or 26, which comes out to be 9.25 or 9.26. Okay, so when we subtract the 4.74, we can get the value of pH. Okay, we can get the value of pH. Okay. Okay, and the problem 4 is calculate the pH of 0.1 molar ammonia solution after 50 ml of this solution is treated with 25 ml of 0.1 molar HCl, and they given that pKb of ammonia is 4.76. What they ask? They ask to calculate the pH of it is a weak base. It is a weak base. Okay, it is a weak base. Okay, and it is a salt. And it is a acid, okay na. So there is a salt formation takes place, okay. So calculate the pH after the solution is treated with 25 ml of 0.1 molar HCl. First we shall calculate the first we should write down the chemical reaction that takes place between ammonia and HCl. So NH3 is treated with HCl, it gives salt, that is NH4Cl, that gives NH4Cl. Okay, so what they asked to calculate 0.1 molar. Okay, so let us calculate we should know the we need in order to calculate the pH we need to, and actually we can calculate the pOH for basic buffer, but they ask to calculate the pH. First we shall calculate the pOH from which we can calculate the pH, right. So pOH is equal to pKb plus log concentration of salt by log concentration of base. Okay, so log concentration of base. So we need to know the concentration of salt that is formed from the ammonia solution treated with hydrochloric acid. So ammonia, let us calculate the millimoles, that is concentration of ammonium chloride. So ammonia's concentration molarity is 0.1 and its volume is 50 ml. Okay na. So 0.1 into the which comes out to be 5 millimoles, and HCl is 0.1 into 25, so which comes out to be 0.25. This is the limiting reagent, and after the reaction is over, okay, there is 2.5 millimoles of ammonia is remained, and this is 0 and its concentration is 2.5 millimoles. Okay, so pKb, already they given that pKb, that is 4.74 2.76 log concentration of salt is 2.5 millimoles and concentration of base is 2.5. So 2.5 that gives 1 and log 1 is 0 and POH is 4.76. POH is 4.76 and they ask to calculate the pH. How can we calculate the pH? pH is equal to 14 minus POH. So 14 minus POH is 4.76 which comes out to be 9.24. Okay. So in this way we can calculate the pH. Okay. And the problem 5 is how much sodium acetate should be added to 1 liter of 0.1 normal acetic acid to make a buffer solution of pH 4 and pK, given that pK of acetic acid is 4.74. Okay, what they ask to calculate how much sodium acetate. Sodium acetate is a salt. Sodium acetate is a salt. They ask to calculate the how much sodium acetate should be added to 1 liter of 0.1 molar acetic acid to make a buffer solution of pH 4. Okay na? So by reading this problem I came to know that it is a acidic buffer. It is a acidic buffer. From this we can write pH is equal to pKa plus log concentration of salt by log concentration of acid. Log concentration of acid. Okay. So to make the buffer solution of pH, what is the pH of the buffer solution? 4 and pK of the solution, pK of acetic acid is 4.74. Okay, plus what they ask to calculate? They ask to calculate the how much. So how much, that is the weight of sodium acetate. So we can calculate the we can calculate the weight of sodium acetate if we know the concentration of salt, because sodium acetate is a salt. They ask to calculate the how much sodium acetate should be added. So sodium acetate is a salt. So if we know the concentration of salt, then we can calculate the weight of sodium acetate. Okay. So pH is 4 and pK is 4.74 and concentration of salt by concentration of acid. Already they given that concentration of acid, that is 0.1, that is concentration of acid. So acid, concentration of acid, we shall substitute that value. Okay. So log. Okay. So I shall take this 4.74 to this side. 4 minus 4.74 is equal to log concentration of salt by log concentration of acid. This gives 4 minus 4.74, that is minus 0.74. It is equal to log concentration of salt by concentration of acid and the concentration of acid. Okay. So I shall take this logarithm to this side, that is anti-log of 10 power minus 0.74 is equal to log concentration of salt by concentration of acid. Okay. So we shall we can rewrite this equation as sorry, I am one step earlier. 0.74 minus 0.74, we can write this as plus 0.74, and when we multiply the equation with the negative sign, and which becomes a log concentration of acid by concentration of salt. When we multiply this equation with the negative sign, this fraction is inverted. Okay. So 0.74, and log, and now we can take this logarithm into this side, that is 10 power 0.74 is equal to concentration of acid. Already they given the concentration of acid is 0.1 into concentration of salt. Okay, let us calculate the anti-logarithm of 0.74. Okay, and it can be written as 0.7 plus 0.04. Okay, so it is equal to 0.1 by concentration of salt. Okay, and it is in the form of m plus n, that is 0.7 into 10 power 0.04 is equal to 0.1 by concentration of salt. Okay, concentration of salt 10 power 0. Anti-logarithm of 10 power 0.7 is 5. Okay, h comes out to be 5 and its value is 0.04 is 1.09. Okay, 1.09. Okay, 1.09, and it gives 0.1 by concentration of salt. Okay, multiplication of 5 into 1.09, that gives 5.45, that gives 5.45. Okay, I shall all these values are I have the values here to decrease the waste of time, right? Okay, so 5 into it gives 5.45 is equal to 0.1 by concentration of salt, and concentration of salt is equal to 0.1 by 5.45. It can be written as multiplying with 100, it is 100, and 10 by 545, which gives 10 by 545, that fraction which comes out to be 10 by 545, which comes out to be 0.018, that comes out to be 0.018. So the concentration of salt is 0.018. So concentration is nothing but molarity. So concentration is nothing but molarity, because for sodium acetate and acetic acid, for acetic acid and its salt, molarity is equal to normality. So we know the formula, molarity is equal to weight by gram molecular weight into, it is a 1 liter solution, 1000 by 1000, which gives 1. Okay, molarity is 0.018 and weight is equal to, weight by gram molecular weight of sodium acetate is 82. So weight of sodium acetate is equal to 0.018 into 82. Okay, which multiplication of 0.018 into 82, which gives 1.50 grams, 1.50 grams. So in this way we can calculate the weight of sodium acetate added. Okay, this is very important problem in NEET and JEE. Okay. Okay, we shall do more problems in the next video, because time is very already I take 40 minutes of 40 minutes for this lecture. Okay, we shall do more problems in the next video.